Welcome, everybody. I'm going to give one more minute for folks who are still trickling in, and then we'll begin. Welcome to everybody. I put up here on the whiteboard, but if you can enter your name, where you're joining us from, what kind of graduate school you're interested in, so that we can all take a moment, just meet each other here. All right, we're going to get started. Welcome to everybody. If you haven't yet introduced yourself in the chat, go ahead and do so. And we're going to get started. So I'm Rina. I'm an instructor here with Manhattan Prep. I teach GRE classes and GRE for MBA classes, and I do these webinars once a month of the free GRE Prep Hour. I've worked with Manhattan Prep since 2012, so a pretty long time. I've taught both LSAT and GRE. And love working with students and helping students get to aha moments and achieve their goals and support them in this process. So FYI, I use the chat and I'll sometimes ask you guys questions and ask you to put your responses in the chat. I know there is in this webinar style Zoom room, there's also like polling feature and ask a question feature, but I really just use the chat. So if you have a question and want to put it in the chat, put it in the chat. The like question asking function is basically the same as the chat, and having more than one chat, too confusing. So just the chat. And if you want to send the question privately, you can send it just to panelists, or if you're comfortable having everybody see the question, you can send it to everybody, but you're welcome to ask questions throughout as well. So I'm going to grab my slides for the session tonight and we will begin. Welcome to you all. Sorry if I missed your name or if I misspelled it, which might have been my fault or might have been the Zoom autocorrect fault, but anyway, great to see everybody. Okay. So tonight we're going to be doing a quant session, and I can't remember if it was you, Megan, the Megan who said you were in the last session, the last reading comprehension session, but I feel like it was you that you were like, oh, when is there going to be a quant session? Because that's what I want to work on. So if that was you, tonight is a quant session. And to everybody else, tonight's a quant session. So we're going to be focusing on specifically combinatorics. So it's combinations and permutations. This is, I'll come back to that slide in a moment. This is a topic on the GRE that you aren't going to get like a million questions on. I recently retook the GRE. That's part of like my Manhattan Prep, staying sharp situation. And I had 3 combinatorics questions on my GRE, and talking to other instructors and my students, that seems to be about the trend these days. You're going to see maybe about 3 of these on your test. So it's a topic that's a small topic, but that you will see on test day in all likelihood. So what we're going to see, we're going to talk about the fundamental counting principle and building off of that. And I'm going to specifically be teaching a method for solving these problems. There's a lot of different ways you're going to approach these problems, but I'm going to be teaching one method tonight, and that's the slot method. I really like using this method because it allows us to deal with twists and turns, I think, a little bit more easily than if we're just memorizing a formula and plugging it into the formula. If we only have the formula as our only tool in our toolkit, when something is a little bit different than what we anticipate, that can really throw us. So if we have a more sort of logic-based conceptual approach, which the slot method is, it's a little bit more of a like common sense understanding approach. I think you're much better equipped to deal with twists and turns. So I'm teaching the slot method tonight, and we'll build up problems in increasing difficulty, and we'll see some twists and turns at the end. Some of the problems that we'll see tonight are coming from this 5-pound book. Other ones I just wrote for tonight. This book is our #1 bestseller. It's available on Amazon. It has lots and lots of practice problems. So if after tonight you want more practice with this kind of problem or any other kind of problem, there's a bajillion problems. The exact number is a bajillion. There's a bajillion problems that you can find in this 5-pound book. Okay, So to begin, what are combinatorics? This is a word that honestly I did not know until I got into test prep. I was like, what are you talking about? So these are the problems that are combinations and permutations, and we're basically they are advanced counting, our combinatorics. It's like how many ways can you shake hands in a room of 100 people, things like that. So it's counting, but it's counting usually more possibilities. Like I love to count on my hands, to be honest, right? Like I love using my hands, but it's more possibilities than our fingers and toes. So what do we do when we're trying to shake hands with people? There's 100 people in the room. That's a lot of handshakes, right? I probably will get tired or make a mistake if I'm counting it on my fingers. So combinatorics, combinations, permutations is how we do these more advanced counting problems. So to begin applying the fundamental counting principle, I have a little problem that puts this into play. I'm just pulling my timer here on the side. I'm going to give you guys 1 minute for it. Now, if you look at the chat right now, it might be to panelists and attendees. Wherever you are, switch it just to panelists. I want you to send me your answer when you have your answer. 1 minute for this one. Go for it. All right, that is time. Oyen, I saw you typed in that you can't see it. I think that's on your end because I'm getting lots and lots of answers coming in here. So I think folks are able to see it. So maybe try quitting and rejoining the session. All right, so let's see here. For this one, this is applying our fundamental counting principle. And essentially the fundamental counting principle is when you have options, you want to multiply them. So one way I could picture this is like I have these 5 appetizers that are like 5, I'm depicting these as 5 lines, and each one of these lines I can pair with each of these 6 main courses lines, right? So each one of them has like 6 more branches that can come off of them. So already I'm at 30, but then each of those little branches that I've made, I can pair with my 3 desserts. So right, each line I can pair with every single other line after it. So it's making almost like, picture those fractals where it's like more and more lines are coming off and off and off. And this is illustrating our fundamental counting principle, which is that when you have options, you want to multiply them. So our right answer here is 90 meals. We're going to multiply our options when we have them. And this is the principle that we're going to be applying to all our next problems. So again, to summarize, it's when you have options, you want to multiply them. Let's apply this to another question. Here it is. I'll give you guys 2 minutes this time for this one. Go for it. All right, that's time. I'm seeing lots of answers coming in. Now, one wrong answer that I'm getting from a lot of people, and I have a guess as to why lots of people are picking it. So I want people to think about why this is wrong. So the wrong answer that I'm getting from quite a few people here is 30. And my guess as to why a lot of folks are picking 30 is they're like, okay, 3 roles, 10 candidates. Rina said, when you have options, multiply them. 3 times 10. So put into the chat to everybody. So take a moment and think, but then when you have a thought, type to everyone, why aren't our options the 3 roles times the 10 candidates, right? Like, I totally understand the thinking here. You're like applying the thing I just said, right? But why isn't that quite what we're gonna do? Okay, good. So I'm seeing some notes about, right, we can't have the same person more than once, but there's another element here. Ultimately, we're not multiplying that 3 in this situation at all. Why aren't we multiplying the 3 in here? So there's something about, we can't have the same person over and over again. Good, right? Like Madeline is saying, like, I can't pick Madeline, 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 but why don't I end up multiplying the 3? Isn't the 3 there for a reason? Good. Okay, right. We're looking for our total teams. We're looking for distinct teams. Good. I love what Oyen is saying, right? Each person has the opportunity to be in each of the roles. So think of the things we're multiplying are our candidates. When we have options, you know, when I'm thinking about like the menu problem we just saw before, I'm not thinking, oh, but there's an appetizer, there's a main dish, and there's a dessert. That's 3 kinds of food. So I have to throw that in there. No, those are the slots we're filling. And I'm going to teach you the slot method. So the slots we're filling are, you know, what kind of food is it? Or what role is it? But we're filling it with foods or with people. So our options are the candidates or the applicants or the menu items that we're filling in our slots with. So my approach here is I'm going to make 3 slots. I want to deal with the number 3, but the 3 is going to be, it's the 3 spots I'm filling. And as several people are saying, right, we're trying to come up with distinct executive teams. So I'm going to label my 3 slots here because they each have a different role. So let's say CEO, COO, and CFO. So I have these 3 roles and I have 10 people I can fill into this first spot. But as several people said, can't be in more place than once. I can't have, you know, Brajesh as CEO, COO, and CFO simultaneously. So once I pick my CEO, whoever it is among those 10 people, I've only got 9 folks left for the next and 8 folks left for the one after that. So my options are 10 choices for what, you know, I can call it CEO, but I could call it any of these roles, but 10 options for the first role, then 9 options for the second because I picked someone for the first one, then 8 options for the last. Altogether, this multiplies into 720. So this is our answer, is 720. So I'm thinking, what are my slots to be filled? That's not what I'm multiplying. Those are the places where I'm going to put in my candidates. And then I'm putting in my candidates and I'm remembering that you can't have someone in more than one place at the same time. So I'm going to decrease by 1 as I go, and I'm going to multiply all those together to get 720. Okay, so let me show you this summary here, and then I'll ask you what questions you have. So if you're confused right now, start to type in your question, but I'm going to show you the summary at the same time. Okay, this is what I just showed you, but this is our process so far. I'm making slots for every decision. Then I'm going to label the slots, and we'll come to why labeling the slots is important in a moment. Then I'm going to fill the slots with the number of options for that decision, and I'm going to multiply across. So these are my steps so far. Okay, what questions do you guys have at this point? Yes, right. So Caroline, this is an approach that we can take for all of these questions. We're going to add to it as we keep going, but this is sort of the beginning of what we're going to do for all of these questions. There is also an equation that you can memorize for these kinds of problems. It's like n minus r factorial, but I actually recommend learning the slot method instead because it's a little bit more common sense and it helps you understand the why behind the formula, which will help you as these problems add new layers. I'm so glad it's feeling helpful, Harley. Okay, so we're going to keep going. Here's another one, and this is a little bit different. So think about why this one is different. 2 minutes, go for it. Very good. So some folks are telling me why it's different. Very good. Also tell me what your answer is as you do it. So how do we incorporate the way that it's different? All right, let's discuss this one. And so between these two problems, we're going to see sort of the main scaffolding for all the questions on this topic that you're going to see. So this one is different because order doesn't matter, or another way of putting it is it's all the same roles. So last one we had these distinct places to put people, but this time, hey, they're all being considered for the same role. So what does that mean for us, right? Do I want to do, I'm filling it. So I've made my slots. I've labeled them each S for sales. I say, okay, I have 10 candidates for the first one, 9 for the next, 8 for the next. Now someone had typed into me, oh, we have 3 different pools of 10 candidates. We do not. So read very carefully here. We have just one pool. We have a pool of 10 candidates, and they're all being considered for these same positions. So we don't actually have 30 candidates. We still just have 10 candidates, but this time we're filling in these identical slots. Now, why is this different? It means we've overcounted by quite a bit. So imagine here a scenario where I'm going to pick the 3 candidates of Bob, Paloma, and Lee. Now you can see in the bottom left-hand corner, I'm imagining the scenario where there's CEO, CFO, and COO. With just those 3 folks, I can make 6 different teams. I can have Bob as the CEO, Paloma as CFO, and Lee as COO, or I can shuffle them around all these different ways. And those are different executive teams, right? Because they're performing different roles. But in this case, where they're all like sales rep, sales rep, sales rep, it's the same team. So all these 6 teams, all 6 of these teams become, they're just one team in this case. And they're just one team because all the roles are the same. So what does this mean for our approach? We're going to add one step to our process. So we are making slots for every decision. Then we're going to label the slots. We're going to fill in with the number of slots, and then we're going to multiply. But then we're going to take out all of the ways we've overcounted. We're going to divide out by our overcountings. Now, in this last one here, we had three repetitions of our 3 S's. We had 3 repetitions. So if I'm like, how many ways can I arrange these 3 S's? This is getting a little conceptual here. So if this explanation doesn't quite jive with you, I'll give you the like quick and dirty, here's what to do thing in a moment. But how many ways can I arrange 3 S's? Well, I have, S1, S2, S3 for my first spot. Then I have 2 left for the next, and then I have 3 for the third. So the short version is what we're going to do is for every repeated slot, so every repetition that I see, I'm going to divide by that number times all the numbers less than it, which is what factorial means. So right now it says factorial. So factorial, this is a math term. It means multiply an integer by every integer less than it going down to 1. So here, right, if I have, let's say 4 factorial, and the exclamation point is what factorial stands for, is the way we symbolize factorial. It'd be 4 times 3 times 2 times 1. So I'll note factorial, this is exclamation point. Or 3 factorial is 3 times 2 times 1. So it's just the number times all the integers smaller than it going down to 1. And that's because that's all the ways I can arrange those repeated elements, which is how much I've over counted by when it is a situation where order doesn't matter or where our roles are the same. So in this case, right, I have 3 slots. Each of them is an S. I have 10 folks, so I'll label here S, S, and S. I have 10 options for my first, 9 for my second, 8 for my third. That multiplies into 720, but I want to divide out by all the ways I can arrange those S's. So I'm going to divide out by 3 times 2 times 1, which is 6. So I'm going to divide by 6. I'm dividing out by all those repetitions factorial to get 120 as the final answer. So again, our process, making slots for every decision, labeling the slots, filling them and multiplying, and then if any labels are the same, divide by the factorial of the number of identical labels. Okay, Ekaterina says, could you quickly mention when we would divide by the factorial and when we would not? So we will divide by the factorial when all the roles are the same. We will not divide by the factorial when the roles are different. That's it. What other questions do you guys have at this point? Why? Okay, so Garrett is, why is the factorial the amount of repetitions, right? So maybe let's go back to this one here. So the CEO, CFO, COO example I had, Bob, Paloma, and Lee, right? How many ways can I arrange Bob, Paloma, and Lee, my 3 characters here? Well, I have 3 options, either Bob, Paloma, or Lee for my first spot. I have 2 for my second. I've picked Bob, now I'm between Paloma and Lee. Then I've picked Lee. Paloma's the last one left. So it's all of my options, how many ways I can shuffle them around. Tiana, we won't keep just using 10, 9, and 8. Tiana's like, why do you only use 10, 9, and 8? We won't keep doing that. I just wanted to show 2 very similar problems where we're hiring from a pool of 10 candidates, where the only difference between these was in one case we had distinct roles, and the other case we didn't have a distinct role. Megan, yes, we're going to see that in a moment. Okay, let me just scroll and see if there's any other questions that. Okay, great. I'm going to keep going and we'll see. We're going to keep practicing this. Okay. So again, I'll say the process again. Make slots for every decision, label the slots, fill the slots with the number of options for that decision and multiply. Then if any of the labels are the same, that's why we want to label our slots, divide by the factorial of the number of identical labels. Okay, here's another question. Go for it. Okay, good. So I'm seeing some questions in here of like, would it be easier to look at the sort of teams individually and then put them together? Good. So when we have subcategories, we want to, and then I'll give you guys another moment here. So when we have subcategories, calculate, we can make it into all one line, but I think for the sake of clarity, let's say calculate each subcategory separately. And then multiply together, because remember, when we have options, we want to multiply them because we're picking hurdlers and sprinters. We're going to put them all together. So, and then multiply. So take another minute here. Like, how many ways can I pick these hurdlers? How many ways can I pick these sprinters and put them together? So take another minute on this one. If you guys got 20160, it is too big. I'm seeing a couple of people come in with that. Too big. You're right. It's too big. Okay, let's discuss. So put in and okay, let me scroll up for a second just to see the questions here, and then I'll give a question for you guys. Good. Okay, so Garrett, I think you're thinking about it a little bit too complexly. Like, to actually think through all those scenarios, you'd end up sort of counting a whole lot of things. So I'm giving you ultimately a shortcut here. No, don't memorize. So Maya asks, memorizing different factorials. No, just you have a calculator on the GRE, use it. So I want you guys to put into the chat to everyone, what are our first two steps? Like, what slots should I be making? What slots, or should we be making? Should we make? And how do we label them? In other words, like, what slots are we trying to fill here? What spots are we? Good. Okay, great. Megan says 4 S slots and 3 H slots. So I'm going to make these. So, right, my slots are the roles that I'm filling. So far, I'm not filling them with anybody yet. These are just the roles that I'm filling. So I've got 4 sprinter slots. And I've got 3 hurdler spots. Now I'm going to fill it with my number of options. Oops, I didn't mean to move that. I'm going to fill it with my number of options. And here I have 2 different pools. So 7 people are trying out for the sprinting slots. So I'm going to use that pool to fill in my sprinting slots. So we've got 7 people to choose from for the first. And remember, right, I can't have a team that's like Eden, right? If I've picked Eden, then I have 6 people left for the next, 5 for the next, 4 for the next. Hurdlers, 4 different people, right? So I have 4 options for my hurdlers, my first hurdling spot, 3 for the second, 2 for the third. So we've finished our first 3 spots, right? We want to make slots for every decision, label the slots, fill the slots with the number of options to that decision and multiply. Then I want to look at my labels and think, what am I going to divide out by? This is because, right, a team of Eden, Megan, and Rebecca as the hurdlers is the same as Rebecca, Megan, and Eden, or Rebecca, Eden, and Megan, and so on and so forth. So I've overcounted by these arrangements. So I'm just going to write to the side. Here are my numbers so far. 7 times 6 times 5 times 4. This is so that I can make cancellations. I'm just going to put them on the side. You can have it all in one line if you want, however you like to do it. I like to then, once I've sort of figured out the label situation, I'm like, let me make this look a little bit nicer for myself. So I'm going to divide out by all the ways I can arrange my repetitions, factorial. So in this case, I have 4 S's. I need to divide out by all the ways I can arrange those 4 S's. That's 4 times 3 times 2 times 1. And then I've got 3 H's. I got to divide out by all the ways I can divide those 3 H's. So I'm dividing out by 3 times 2 times 1. The reason I like to actually write this out, this is just my personal taste here, is I like to make cancellations before I multiply. Otherwise, I'm dealing with these like huge numbers that maybe I don't have to deal with. So I'm like, oh my God, all those 3's and 2's cancel out. Yay. And then I'm like, oh, this 4 cancels out with this 4. And the 3 and the 2 together cancel out with the 6. So I've canceled out a whole lot. So I'm left with 7 times 5 times, well, let's say 7 times 5 for my sprinters. That's 35 times 4. I'm only left with 4 for my hurdlers. I multiply all of that together, because when we have options, we want to multiply them to get 140 teams that we can get to here in the end. So 140 is our answer. Okay, what questions do you guys have about this one here? Yay, Megan, I'm so glad it's a helpful method. Oh my God, Maya is correcting my spelling of hurdlers. Right, you can tell this is one that I made up. I've never done track. So I was like, hurdle, that's something, thank you. The factorial, yes, right. So Caroline says the factorial is the number of options. Exactly. So well, I shouldn't say exactly because I'm not sure exactly what you're saying. The factorial is, that's the operation where we do big number times all the numbers smaller than it. And we're going to divide by that by our number of things that we repetition. Great. Bringing back statistics class, hopefully not in a traumatic way. Okay, let's keep going. We're just going to keep applying this. So the next one doesn't add any wrinkles. We're just going to try it again. Here we go. I'm keeping the approach on here, right? So you've got how to approach it. Here it is. Go for it. I'm going to let you guys know that a couple of people are getting the wrong answer of 1440. And I would say to those folks, that's incorrect, but very close. I think I have a sense of what you're doing wrong. Think about, there's a spot where we need to divide something out. Where might that spot be? Okay, very, very good. So I'm going to make my slots. I'm going to label them. So I'm picking just one kind of lettuce. I'm picking one kind of nut. I write, these are the slots I'm filling. I'm filling the role of lettuce here with these 3 auditioners for the role of lettuce. I'm filling the role of nuts with these 4 kinds of nuts that are hoping to be the nut in my salad. I'm picking 2 kinds of cheese because I love cheese, and 1 dressing. So I'm labeling here. Then I'm saying, okay, right, I'm not going to fill my lettuce slot with a nut. I'm filling it with the lettuce. So I've got 3 lettuces to choose from. I've got 4 nuts. Then I have 5 cheeses for my first cheese, but then I'm picking one of them. So then I have 4 cheeses for my next cheese and 6 dressings. Now, if I multiply all of this together, I get 1440, which is what a couple of you guys got, or a bunch of you guys got. Well, we need to divide by something. What do we need to divide by? So it's not 1440 isn't our final answer. So type to everybody, what do we need to divide by and why? What do we need to divide by and why? Good, good, okay. Cheese, because there are 2, right? The repeated groups, when we have that repetition, right? The cheese is repeated, Picking blue cheese and cheddar cheese is the same as picking cheddar cheese and blue cheese, but I counted it like it was different. So I need to divide out those repetitions. So in this case, I just have 2 repeated slots. So I'm dividing out, I'm going to divide by 2 times 1, which is 2. And that gives me to my final answer, which is 720 salads. So many salads distinct salads I can make at this salad bar. Very good. Okay, what questions do you guys have about this one? Okay, so Caroline says, my first instinct was to draw 3 slots for lettuce, 4 slots for nuts, and so on, right? So this is a very, very common mistake that folks make. They're like, what do I draw for my slot? Like, which are the slots and which are the things I'm inputting? Think about the slots are what you want at the end. At the end, I just want 1 kind of lettuce. I just want 1 kind of nuts. In the end, I just want 1 CEO. In the end, I wanted 4 hurdlers or 4 sprinters. So I'm going to put down 4 sprinter slots. So the slots are, what do I want at the end? The numbers I'm putting into the slots are how many I'm starting with. So I'm going to winnow down from the big number of auditioners to like, how many roles do I want to catch at the end? Rebecca says, why don't we divide by 3 times 2 times 1? We don't want to divide by that. We divided by 3 times 2 times 1 on a previous one, but we're dividing by whenever we see a label repeated. So these are all distinct. Lettuce, nut, dressing, those are all distinct. So I'm not actually overcounting anything here. I'm only overcounting when I have a group where the role they're filling that they're auditioning for is the same role. That's the only time I'm going to repeat. And I'm like, how many extra roles do I have? How many times is it repeating? In this case, only twice. So that's what I'm dividing by, right? So I'm dividing out by whenever I see that repetition, how many of the repetitions. Harley says, so this is different from our very first, good, right? Harley, this is slightly, right? The very first one we did is something very similar with like, oh, we have all these different meals, right? Here I just added the extra wrinkle where we're picking 2 cheeses, right? So it's same fundamental counting principle, but we're adding it, oh, now we know we need to divide by those repeated spots. But otherwise it is the same, right? So we're doing all these same things, but we're just adding little wrinkles here. Okay, great work, guys. I'm going to give you another problem. This has an additional wrinkle. So I'm going to give it to you for, let's say I'll give it to you 1.5 minutes just on your own first, and then I'm going to give you advice on a first piece of advice on how to deal with this wrinkle. Here it is. All right, guys, wherever you are, pause. I'm going to give you some information or thoughts, and you might or might not want to change your answer based on what I say. So the first thing I want to say is a good additional thing to remember with these problems is when you have constraints on these problems, start there. So in this case, like our middle stripe is constrained, we want to start with that one. So that's one thing. Another thing is, and this is similar to a real GRE problem, right? So you're like, does order matter or not? We kind of have to use common sense here a little bit. It's not explicitly stated. So I'm going to tell you guys on this one, order matters, right? That tiny little triangle stripe at the end is different than that big stripe on the left, even if it was like a rectangular flag, right? We have like different countries where they rearrange the color. So order matters here, right? That's something to remember. And the last thing I want to just highlight for everybody is that no colors can repeat. So So that might have been a mistake you made where you assumed you could repeat colors. So let me give you guys another minute with this one with these pieces of info in mind. All right, let's walk through this one. So remember what I said of when you have constraints, start there. So in this case, our middle panel can only be 2 colors. So I'm gonna put 2. I've made my slots. Oh, sorry, taking a step back, making slots and labeling them. I made them here on the bottom right. Earlier, we were like, which are the slots, right? The slots are what I want at the end. In the end, I want a 3-stripe flag with a left stripe, a middle stripe, and a right stripe. So I have two options for my middle stripe. Type to everybody. How many options? How many left for left and right? So what numbers should I be putting in my left and right stripe slots here? Good, good. So originally I had 6 total colors. I picked one of them, right? The orange and white are from my original list. Those aren't new colors. They're from my original list of 6. I picked one of them for the middle one. The other one is still in the running for my other stripes. So but I picked one of them. So I have 5 left for, let's say, my left stripe, and I have 4 left for my right stripe. So now I have all my options and I want to multiply. Now, some people are saying 4 and 3. No, because if I pick orange for my middle stripe, I could still put white as my left stripe or my right stripe and vice versa, right? I don't have to knock out both of those from the running for my left and right stripes. So this is an important point, right? Hey, the middle has to be orange and white, but everything else is fair game. So we're left with 5 and 4 here. Now I'm going to multiply. Now, I want you, since a lot of folks were sort of a little bit confused of what numbers here, let me pause here before we keep going. What questions do you guys have about why I'm putting 5 and 4 in here, right? Good, Janelle, right? No color can repeat. That's right. So that's why originally I had a pool of 6 colors. When I picked my middle one, I'm left with just 5 colors left to choose from. But I've only picked 1 at this point, Janelle. I haven't picked 2. So I've only taken 1 color out of my pool when I locked in my middle color. Then once I lock in my left color, I've taken another color out of the pool and I've got 4 left. But I don't need to prematurely take out both of those middle colors that I had as options, because I could have a flag that is, for example, like pink, orange, white. That's okay, right? I didn't have to knock out both orange and white from the middle. Garrett says, if you were to start with 6 as the left stripe, is there another way to do a problem that accounts for the change? No, Garrett, really, good. I'm glad that was clarifying, Janelle. Really, the way to do for these problems is start with the constraints. So you want to start by dealing with what's the thing that's a limitation? Because otherwise I'm like, which one? Like there are ways I could do it, but it was so much more complicated. I'm like, but which, then if I picked white and yellow, how many options do I have for the middle? Or if I didn't pick them, how many options do I have? So I have to really think through all these scenarios. So instead, start with the constraint, and then actually you're thinking through fewer scenarios here. Okay, what other questions do you guys have? Yes, Katerina, right? They would give you a drawing as maybe a little bit more beautiful than the one I made here, but so they wouldn't give you a photo, but they could totally give you a little diagram. So now, okay, great. I'll just stop talking for a second. continuing, what other questions do you guys have? Okay, so let me tell you, 40 is the right answer. I don't need to do any dividing here because none of my labels are the same, right? Pink being on the left or pink being on the right, those are actually different flags. So I'm not over counting by all the shufflings of everything. Order matters here. So 40 is the final answer. I'm going to give you guys one more challenge question. Oh, actually, you know what? Before I'm going to do that, I'm going to show you another way you could think about this one, which might help you with the next one, which is quite twisty and turny, and I'll just talk through that one. So another way I could think about this one, and remember, this is so that I can illustrate for the future, is maybe I'm going to think I'm going to lock in my middle slot. I'm going to be like, this is going to be orange. I'm just going to straight up be like, this is the orange one where the middle is orange, and this is the one where the middle is white. If the middle one I picked orange, there's only like one choice for the middle, and there's only one choice for the white. So if I picked my one color, my orange for the middle, then I have 5 options left for the first, for the next one. So then I have a total of 20. So I have 20 flags where orange is the middle, where just orange is the middle. And if white is the middle, I also have 20 different flags. 5 are left, then 4 are left for the right. I have 20. So if I have 2 ways of getting to where I want to go, so 2 ways of getting there, I can calculate them separately. And then add. And another way of phrasing this is if we have an or situation, we can add up the options. So when we've had ands before. So I want a left stripe. When we have and, we want to multiply, right? We want a left and a right and a middle stripe. An or situation is I want white or orange in the middle, right? So those aren't happening simultaneously. It's like 2 different ways. It's like 2 different routes. I'm not going to take both routes, 2 different routes. I can add them up at the end. Okay, here's the last one. Garrett is asking, might there be a question that combines combinatorics and geometry? I don't know that I've seen one in GRE materials, but certainly topics can be combined, right? Like absolutely, it's fair game to combine topics. Here's the last one. It's a tricky question. It combines all of these sort of tricks and turns, and I'll walk through the solution. By the way, if the next one you're like, woof, that was too much, went over my head, it's super tricky. So no worries if this feels a little bit beyond. Okay, so to summarize, right? Make the slots, label them, fill and multiply, divide out repetitions, start with your constraints. There's more than one path to get there, add them up. Here is the last question. Oh, there we go. Okay, here's the last question, 2 minutes. All right, guys, super tricky problem. I'm going to tell you a solution to this one. If it doesn't quite click for this one, you know, again, let this one wash over you. This is a tricky question. And it's an application of many of the things we've talked about. So again, I want to start, remember what I said, I want to start with the constraints. Now, when I'm labeling my spots here, they're all distinct. You can be first in line, second in line, third in line, fourth in line, and fifth in line. So all, you know, order matters here. Every single slot is distinct. But then I have this constraint of Beanie and Carla must stand next to each other. So where do I put them though, right? Like, where do I put them? So what I'm going to do is I'm just going to make a choice, and I'm going to start by putting them at the beginning. I'm going to put like Beanie Carlos here at the beginning, and it could be Beanie Carlos or Carlos Beanie. So in other words, if I put them at the beginning, I'm going to circle this. I'm just going to choose to put Beanie Carlos at the beginning. I have 2 times 1 ways of arranging Beanie and Carlos. So I have two options. Maybe I'll put that in another color here. I have 2 options for that 1-2 spot. Oops, not 3. I have 2 options for that 1-2 spot where Beanie and Carlos are going. So I'm going to put the number 2 here. Now I've locked in my 2 people. I've locked in 2 people. I've got 3 more to place. I've got 3 places, 3 folks that can go in this 3rd slot, 2 in the 4th slot, and 1 in the 5th slot. So here I'm going to write, I've got options. I multiply them. 3 times 2 times 1 times 2 is 12. But remember, I made a choice to put them at the beginning. So I want to take a moment and think, what if I put them somewhere else? I could put Beanie Carlos in spots 2 and 3. So I'll put them here. Or I could put them in spots 3 and 4. I could put them here. Boom, you guys are you're getting it, right? Or I could put them here. Now, I could go through and figure out all those scenarios, but actually they're all the same as the first one, just different variations. I've just put my like Beanie Carlos combo in different places, but otherwise the numbers are all the same. So I've got 4 versions of this arrangement. I've got 12 when Beanie Carlos are first. I've got 12 when they're second, 12 when they're third, and 12 when they're fourth. Now remember, when I have different ways of getting where I want to go, I add them all up in the end. 12 plus 12 plus 12 plus 12 is 48. So I want to add them because these are or. Beanie Carlos could be first or second or third or fourth, right? Like I'm not simultaneously going to put them in all these places. These are different ways of getting there at the end. So 48 is our right answer here. Okay, Natalia says, why wouldn't you put 2 times 2 for Beanie and Carlos? That's because Beanie can't stand next to Beanie. She's got to stand next to Carlos. So there's 2 options for the first spot, Beanie or Carlos, but then whoever's in the first can't be in the second. So it's 2 times 1. Let me scroll up and see what other questions. Oh, good. I'm seeing lots of woohoos. That's music to my eyes. Let's see. Would this, Hyla asks, would this be hard on the GRE? Absolutely. Maya says, would you suggest treating them as a unit? Totally, right? I could be like, I tied a rope around Beanie and Carlos. This chunk has to be in these 4 spots, but then I want to remember that there's 2 ways of doing that chunk, right? And I'll multiply that by 2 at the end, but totally. Good, right? Okay, so having the right idea, but spending a little bit too much time on it, but you guys are, it seems like you guys are really getting them to the right spot. Yes, Maya, I love that way of saying it's 4 people. That would be a really smart way of doing it. And then just remember to multiply by 2 at the end. Okay, very, very good, guys. So I'm going to stop sharing. We're almost at the top of the hour. So that's the end of this lesson on combinations and permutations. Oh, Natalie, I'm just going to say out loud your comment that makes me so happy. Natalie says, I think this is the first time in my life I understand this. I'm so happy to hear that. So here's our process. We're going to make slots for every decision. Then we're going to label the slots. Then I'm going to fill the slots with the number of the options and multiply. But then I'm looking out, oh, are any of my slots the same? If so, I want to divide by the factorial of the repeated labels. Then I have these 2 extra tips here for when you find twists and turns. Start with your constraints. Then if there's more than one path to get there, add them up. All right, let me stop screen sharing. So great to meet you guys. So we have 5 more minutes. I'll stick around if you guys have any other questions. You know, it might be on this topic, or just if you're like, hey, I have this overall studying question, happy to answer. Otherwise, if you're done, go ahead and enjoy the rest of your night, and great to meet you all. And thank you guys for the kind words. So nice. Natalie says, suggestions for the night before the exam. I say, get a good night's rest, maybe go over a couple of notes, but don't cram at the end. Caroline asks about, how can I find an affordable quant tutor? I would check out Craigslist. There's a lot of folks out there that are sort of like getting their foot in the door, so that'd be great. Oh, Natalie, it's tomorrow morning. Great. So go rest, go sleep. So glad. Yeah, vocab super challenging. Agree. So glad you guys were here and enjoyed the session. Rebecca, any other helpful GRE tips for everyone? I'll say to everybody. Someone else wrote how hard vocab is. Vocab is totally doable, but it's a big mountain. So don't cram the vocab. Start the vocab early and be consistent in your vocab studying. Janelle, if I have books from 2010, 2012, can I use them to study for this year's GRE? Absolutely, right? Like things might have changed a little bit, but overall the content is the same. So I think those books will serve you well, right? Their emphasis of, they might be asking a little bit more of this and a little bit less of that nowadays, but overall it's the same content. So glad it was helpful. Any other question? I'm just scrolling up to see if I didn't miss anything. Oh, Caroline says, just starting out, what would you recommend as a very first step? Caroline, take a practice test. There's a free practice test on Manhattan Prep site. Take that. There are free practice tests on the ETS site. Those are the makers of the GRE. That'll give you a great foundation of like knowing where you're beginning, getting a sense of your strengths and weaknesses, etc. Emma, we have 2 free prep hours per month, and every session is a different topic, so different difficulty level. So it's a little bit like you'll go and find out, but but I should say actually all of them are recorded and are on our YouTube. So guys, check out our YouTube because you can see all these past sessions too. And like there's tons of great sessions. We've been doing these for years and years. So it covers a lot. So, and you can see what the topics are. So go and check out the past sessions. Rebecca, okay, well, if it's Monday, that's very soon, but overall, how do you get in more vocab studying? I'd say buy or make flashcards and then just take those flashcards with you, or if we're all at home right now, a little bit more, right, like have them there and just do them at little moments in time, right? So you don't need to do them all at once. Ideally, in fact, don't do them all at once, a little bit at lunch, a little bit before bed, a little bit in the morning, right? A little bit here and there. Caroline, tips for speed on GRE Quant. Do tons of time practice. You'll burn out if you take a million practice tests. So what you should do is mini time sets of 5 questions, 10 questions, 20 questions, where you're doing them timed and they're mixed review questions. In the back of the 5-pound book, there are mini time sets actually. And also there are full sections as well. So I would do those sort of like short time sets so you can practice bopping around. Yes. Okay. Link to the YouTube channel. Let me grab it right now. Yeah, that'll be so helpful for you guys. The YouTube channel is like super duper helpful. All free, obviously. Here it is. So to everybody, if you want to check out the YouTube channel, here it is. Oh, love that, right? Yeah, also actually our app has all the 5-pound book questions in it, and you can get a randomized sample of them too. So you can make many time sets that way as well. Awesome. Thanks, guys. I'm going to close out the session. So good to meet you all, and good luck with the rest of your studies. Bye-bye.